Today we're going to cover the last part of quadratics, which is using the quadratic formula. So far we have learned two different ways of solving quadratic equations. The first method we learned was with graphing, and then we did factoring. So today the method is going to be called the quadratic formula. So let's look at the following problem and try to solve it in the ways that we've learned before. So by graphing and by factoring. So here's my quadratic equation. Remember, it's quadratic because of the x squared term. So I've got x squared minus 2x minus 15 equals 0. Remember, we did this on our calculators before. When we went to the y equals screen, we cleared out what was ever in there, and we typed in the equation that we saw. So we had x squared, remember the x button is right next to the green alpha key, x squared minus 2x minus 15. That wound up being y1, and then y2 was what was the other value. So in this case, y2 is going to be 0. And then we hit graph. So for this graph, if you're not seeing it on your calculator, remember you can hit zoom, and then you go down to number 6, standard. I think I hit number 7 by mistake. We were looking for where the two lines were intersecting. So I see my U shape, but then I'm not seeing the other line. So remember 0 just means the x-axis. So really I'm just looking at where is this graph crossing on the x-axis. Or I'm looking for the x-intercepts. And on this graph, I can see where it's crossing. It's there and there. So remember we would hit second, trace, intersect. Number 5. And that's when we moved our cursor left or right to try to find it. And then you would hit enter 3 times. Enter, enter, enter. So I know one of my intersection points is at x equals negative 3, so that's a solution. When I plug in negative 3 into this equation, it gives me 0. The other solution, we do the same step to repeat it. Second, trace, intersect. When we moved it over to the right, it's got to go over past the hump in the parabola, and there's my cursor again. And I would hit enter, enter, enter 3 times. So my other solution was x equals 5. So we practice that method, and you can always use that method when you're solving. You can do graphing, and you'll get at the answer using graphing. The other method we worked on more recently was when we were factoring. So when we factored, remember I asked you to figure out what numbers multiplied together to give you negative 15, and then added together to give you negative 2. We made our little x diagram. So using your factor sheets, we knew that the factors of 15 were 1 and 15 or 3 and 5. And then in order to get negative 15, I need one of these values to be negative. I know it can't be these two because when you add those together or subtract them, you're not going to get negative 2. So when looking at 3 and 5, I'm either doing 3 plus negative 3 plus 5 gives me positive 2, but not negative 2. So I'm going to try 3 and negative 5. And that gives me negative 2. So I know my two factors are 3 and negative 5. So from there, we were able to create the factored form. And then we worked on setting these equal to 0, or what numbers make those equal to 0. So x plus 3 equals 0, or x minus 5 equals 0. And then here's where we were able to get the same answer. So notice this is the same answer because this is the same problem. We just solved it in two different methods. One using our graphing calculator, or one with factoring. Those are things we learned the last 2 or 3 weeks when we've been dealing with quadratics. Today I'm going to show you a formula that's going to work no matter the problem you're given. So if you're given a problem with a quadratic, this formula will help you get to the answer of what the solutions are. And remember, the solutions are the numbers that make it true, or when you plug it back in, it gives you 0. So the formula, you might have seen it before in middle school, is kind of long. This is the formula. So if you have an equation in this form, which we talked about this when we did finding the vertex when we were graphing, you can use this equation. This is the quadratic formula. So you have the opposite of b plus or minus the square root of b squared minus 4ac divided by 2 times a. It seems like a lot, but really all we're doing is plugging in numbers and solving, so it's just testing your substitution skills. So the first thing we need to work on the next page is just practicing identifying that a, b, and c values, which we kind of worked on already in a previous lesson. So to use this formula, the quadratic equation should be in standard form. Standard form means you start with the x squared term, then the x term, and then the number by itself, the constant. So each of these are in a standard form. They start with x squared, then the x term, and then a constant number at the end. So the a, b, and c values, remember the formula was ax squared plus bx plus c equals 0. So a is the coefficient of the x squared term, the number in front of x squared. B is the coefficient of x, and c is the constant value at the end without the variable. So in this first equation, my a value is 1, my b value is negative 10, c value is 20. Hopefully this rings a bell from when we did the vertex and finding that. Second equation, the a value is 1, the b value is 1, the c value is 2. Next equation, the a value is 2, negative 3, and 5. Here we've got negative 3, negative 4, and 6. This one, there is no middle term, so it's 1, 0, and 15. In this one, there is no end term, so it's 1, 6, and 0. Why it's important to be able to understand the a, b, and c values is that's what we're going to use to plug into the formula that we were given, the quadratic formula. So let's practice it. This one I've kind of started for you. Let's say you're given that same problem. We already know the answers, but I want to show you how the formula gives us those answers. So here's our equation. I want to know the solution. So what are the x values that make this equal to 0? So to start, I identify my a, b, and c values. A is 1, b is negative 2, and c is negative 15. I'm now going to plug those values into this formula over here. So notice, to plug in for b, I have two negative signs. I've got the negative sign in front of b, and then the negative 2 that b represents. So I've got opposite of negative 2. Plus or minus, the square root of, and now I'm plugging in my value for b again. Negative 2 goes in for b, then the squared symbol, minus 4, because that's in the formula, times my a value, which is 1, times my c value, which is negative 15. On the bottom, I've just got 2 times a, which is 2 parentheses 1. So now what's happening is we're just doing some math. Negative 2 is positive 2. The square root of the square of negative 2 times 2 is 4. And negative 4 times 1 times negative 15 is 60. 2 times 1 is 2 on the bottom there. I'm going to show you a trick to help you get through this step a little bit faster. 4 plus 60 is 64. The square root of 64 is 8. And so now we separate this out into two problems because it says plus or minus. So 2 plus 8 divided by 2 is 10 divided by 2, or 5. 2 minus 8 is negative 6 divided by 2, or negative 3. So using the formula, we're getting that same answer we got from those problems we started off the notes on. So a lot of mistakes happen when we're plugging in numbers into this part of the formula. So let's practice that on the next 2 pages, and then we'll see how we do with some homework questions. So for this problem, you always want to start by identifying your a, b, and c values. So in this question, our a value is 1, our b value is 8, and our c value is 15. So the very first step is you're going to plug these values into the quadratic formula. So anywhere I see a b, I'm going to replace the b with the 8. So I have negative, I'm going to put it in parentheses, 8 plus or minus the square root of, I'm replacing b again, so it's 8 squared minus 4 times my a value, 1, times my c value, 15, all over 2 times 1. So right now I'm just plugging in these values for a and b and c into the formula. I'm using parentheses to help with my plugging in. And now here comes the solving part. And here's the trick I was going to show you. Underneath the radical, the square root symbol, this little symbol with the line and the little check mark here, I'm going to type in everything as I see it. So I'm going to type in exactly as I see it underneath the square root and hit enter. So all of this, when I do the math, gives me 4. So I'm going to rewrite my problem here. X equals -8 just turns into -8 plus or minus the square root of 4 over 2. And so now this is a lot easier, right? What's the square root of 4? So to find a square root, you're going to use this key, which is right above the x squared key. So I have to hit second x squared and then type in 4. So the square root of 4 is 2. So I can rewrite this as x equals opposite of 8 or -8 plus or minus 2 over 2. And now this is where you branch. Because of the negatives and the positive sign, the plus or minus, we're going to separate it into 2 problems. So I have -8 plus 2 over 2 and -8 minus 2 over 2. So -8 plus 2 is -6. -6 divided by 2 is -3. -8 minus 2 is -10. Divided by 2 is -5. So when you're thinking quadratics, you're thinking you should have 2 solutions, because remember when we graphed them, we generally found that they crossed at 2 points. It's not always the case, but in general, that was the case. So what this is telling us is that when you plug in -3 and -5 into this formula, into this equation, you'll get 0. Let's try the next one. Always start with your a, b, and c values, and then we just got to plug them in. So a is 2, b is -5, and c is 2. So plugging them into my formula, I have -5, because notice there are 2 negatives. There's a negative in front of b, and then b is a negative. Plus or minus the square root of -5 squared, that's my b value, minus 4 times 2 this time, because a is 2, times c, which is also 2, all over 2 times 2. So remember, on my calculator, I can get some of the work done a lot easier by just typing in exactly what's underneath the square root sign. So I've got -5 squared minus 4 times 2 times 2. That gives me 9. So I can rewrite this. X equals, opposite of -5 is +5, plus or minus the square root of 9, all over 2 times 2 is 4. The square root of 9 is 3, so I've got 5 plus or minus 3 over 4. Once I get to here, that's where I branch it. So there's no more square root sign, there's nothing else, I can branch it. And I'm separating it out into 2 problems, 5 plus 3 over 4, or 5 minus 3 over 4. So I get 8 over 4, which is 2, or -2 over 4, which is -1/2. Sometimes you'll get fraction answers, so don't worry. But right now we just found the solutions. These are the numbers that when I plug them back into my original equation will give me 0. This is very difficult, so I want you to take your time and practice. Right now let's focus on setting up our formula correctly, and then we'll go from there. Good luck.